Well, hello everyone. Welcome to the webinar, Powering the Future of Energy Storage, sponsored by MEANWELL and Sager Power Systems. I'm Lee Teschler, Executive Editor, and I'll be your moderator today. Just a couple of housekeeping details before we get started. You'll see several boxes on your desktop, all of which can be moved around and resized to suit your preferences. You can enter your questions in the Q&A box, and they'll be addressed after the presentation. Another box to note is the additional resources box. This box has websites and other information on this subject. We also have a tweet box right on the desktop, so feel free to tweet any interesting points right from there. There's a list of hashtags for you to use. And now let's meet today's speakers. Kylie started as an application engineer at MEANWELL and is now involved in product development, product launches, and market positioning. He has a BS in electrical engineering from UCLA. David Miskell is a power system sales engineer and has worked in the power industry for over 25 years. His BS in electrical engineering is from Southern Illinois University in Carbondale. And Dave is also our first speaker today, so without further ado, Dave, the floor is yours.
Thank you, Lee, and thank you to everyone who joined us for today's webinar. Before we get to our featured speaker, I want to take a few minutes to give you a quick overview of MEANWELL and Sager Electronics. MEANWELL is ranked #1 in global sales for off-the-shelf power supplies. They're a leader in new products and have grown their portfolio by as much as 10% each year through new product introductions. The MEANWELL engineering team is developing high-power, digitally controlled power supplies that address the alternative energy and energy storage market, which Kai will discuss in his presentation. The MEANWELL has a comprehensive assortment of AC to DC, DC to DC, and DC to AC power conversion products, including DIN rail, battery chargers, board-mounted power modules, external adapters, and they are a market leader in enclosed power supplies and LED drivers with over 10,000 standard part numbers in their portfolio, covering from a half a watt to 25,000 watt. MEANWELL's power conversion products serve end markets that are essential to all of us: industrial, medical, lighting, horticulture, telecom and wireless, building automation, as well as energy storage and alternative energy. MEANWELL has a global footprint with diversified manufacturing locations in Taiwan, China, and the Philippines. They have customer and engineering support in Fremont, California, and they're the fastest growing power supply manufacturer in the world because of their commitment to engineering, quality, and support, which makes them, and also makes them a price leader. Sager Electronics is a leading distributor of MEANWELL in North America. Sager has the #1 inventory position with over $7 million centrally located in our warehouse in Carrollton, Texas. We are stocking all of MEANWELL's newest products, including the products that Kai will discuss during his presentation today. And the Sager team can assist you with engineering support, samples, and best-in-class distribution services. The main takeaway from this slide is Sager Electronics was acquired by TTI in 2012. This acquisition has given Sager the resources to make some key acquisitions of our own and build a specialized group that I'll discuss in the next slides. Our corporate headquarters is in Middle Mass, and we have 10 sales locations in North America's major markets. We've expanded our capabilities by adding custom solution centers for power, thermal, and battery in Carrollton, Texas, and Lisle, Illinois. Sager Electronics is an IP&E distributor, but in our case, IP&E stands for Interconnect, Power, and Electromechanical. We're specializing in power conversion, battery, and thermal products to support customers with complex design challenges. We will continue to invest in and grow these segments of our business. To highlight the specialization, Sager Electronics launched a sub-brand, Sager Power Systems, in February 2015, which I'm a part of. In this group, we have a team of highly trained, technically experienced professionals working directly with our customers, offering a line card of leading power, battery, and thermal manufacturers, along with custom design capabilities. The team has 14 power system sales engineers and business development reps throughout North America, along with 6 value-add program managers and emerging account specialists. The Sager team is proud of our relationship with MEANWELL, and we'd like to support you with our power or thermal or battery requirements. And now I'll hand it off to our featured presenter, Kai Lee.
Thank you, David. So now let's talk about powering the future of energy storage systems. So first, let's talk about the purpose of energy storage. So of course, as the name suggests, the purpose, on paper or as appears, is to store energy, right? But to look at it deeper, is to store excessive energy and also to enable multitude of mobile and portable applications that are going on in the trends nowadays. And of course, it's also to enable a lot of the renewable energy applications and to make them more efficient or to make them support our daily lives better, to support our power grid better. And that brings to stabilizing the overall energy systems as well as storing energy for backup later. So there are many different ways the energy storage systems can be used. But today we'll talk about what's called a ESS, so energy storage system as the industry calls them. So there are many different types of energy storage as well. And so there's the solar, electrical, there's also gasoline. Gasoline is a form of energy storage as well. And then we have home use batteries nowadays. We all see that. And then also power plants, electric grid, and then hydrogen cells. And so there are many, many different types of energy storage. That's not covered here. But today, we will mainly focus on the electrical energy storage systems. So now let's talk about the different market trends and the drivers for these trends, right? So first of all, this graph summarizes the global stationary and transportation combined projections for the global energy storage market. And the market is projected to increase to more than roughly 2,500 gigawatt hour by 2030, which is about 4 times the 2018 baseline value. So the vast majority of this growth is due to the adoption of electrical EVs, and this speed, the adoption speed is still increasing. So stationary also sees very sizable growth, but it's just not as explosive as the transportation or the mobility energy storage due to the EVs. So this graph here is the projected cumulative U.S. grid-related deployment by applications. And now we're talking about the grid-related stationary. And so as you can see, there are many, many different types of markets and applications this can go into. But if we look at the different bars and different graphs, we see that the peak capacity, energy shifting, and also the residential are increasing the most. And so I think we can ask David to share with us if Sager is currently working with any customers in this in related market and see what's the trend going on, right?
Yes, Kai. I will mention we do have a flywheel energy storage customer, which is a little unusual, and we're not really covering that now. But flywheels are short-term discharge times, what they're good for. Therefore, they tend to be used for 2 hours or less discharge time. We also have a customer on grid-level lithium battery storage project. We developed a DIN rail solution and a cabinet for powering and providing battery backup for a battery management system on a large grid energy storage system. And another customer application we have are for fuel cells. We have a fuel cell customer with a 2 kilowatt fuel cell for use at a residence or small office building. So fuel cells, you really wouldn't necessarily think of them as energy storage, but more of alternative energy source. But they produce energy on demand. Therefore, fuel cells, they have the potential to alleviate some of the electric peak demand issues that we'll be talking, that Kyle will be talking about in a few slides.
Okay, thank you, David. So now let's look at the projected global transportation energy storage deployment. Right, so we'll look at the stationary, now we look at the transportation. So the figure shown summarizes the projected growth of the transportation sector. So SLI refers to the more traditional starting, lighting, and ignition uses. And the SLI applications exclusively uses lead acid today. And they're currently dominating the transportation market. And because they're using all types of vehicles. But they're expected to grow slowly all the way through 2030 following the global vehicle sales. But the actual growth or the actual explosion is from the mobility storage deployments, which are currently a fraction of the SLI applications. And they will likely exceed the SLI for the first time in estimated maybe 2023, and with explosive growth expected through 2030. And mobility storage is dominated by lithium-ion battery applications. But of course, there are some mix of hydrogen cell applications or other battery chemistries that are also included in the data presented here. So yeah, David, so it looks like the mobility power is on the rise. What products, technologies, and services does Sager provide to support this kind of market trend?
Well, Kai, at this time, Sager does not engage with any of the major electric vehicle manufacturers. However, we are engaged with companies involved with lithium-ion battery packs and charging systems in RVs and boats and electric bicycles, asset tracking and robotics, just to name a few. Besides MEANWELL power products, Sager can offer standard lithium battery packs, or we can develop custom battery pack solutions with the associated protection and charging circuitry. Oh, and Sager can offer semi-custom wireless charging solutions up to about 3,000 kilowatts. Besides mobile applications, we have several customers that make portable or permanent off-grid solar and wind turbine battery systems using lithium-ion batteries. Kai, like MEANWELL, we have a diverse customer base for mobile and portable applications.
Okay, thank you. So we've looked at some of the trends and some of the data, right? So now let's analyze the different drivers that are going on in the energy storage market. So of course, we saw that for the energy shifting and peak capacity applications, they're expected to grow very wildly. And of course, this is the key drivers for this kind of trend is the increasing renewable energy project deployment. And there's also, because of these more and more renewable energy sources, there's also increasing needs in the load balancing. And this has to do with how the renewable energy applications play into convert the power and store the power. So there's the load balancing needs. And the residential sector, we saw that it's also expected to grow. And of course, this is due to local energy regulations that are saving this consumer money or giving back to the consumer. And also there's the increasing consumer awareness that is driving them to go green, save the world, right? So the consumer awareness is also playing a big role in the big growth in the residential sector. And finally, if we look at the everything kind of ties or kind of is exploding due to the EV growth, EV adoption. And we're also introducing this term, the mobility storage, that is tied to the EVs. Of course, the EVs are not designed as energy storage initially, but as the deployment number increases in very large number, especially in the future, in a few years, there will be many more EVs on the market. And there's also the trend or concept of utilizing these large number of EVs as energy storage to help with some of our daily energy needs. So, so of course, the EV trend is very strongly driven by a lot of the subsidies given out by many countries around the world, in Europe, in China, or in US. Right? There are all kinds of subsidies to promote the growth. And then there's also the rapid expansion of EV charging infrastructure that will eventually be able to be integrated with these different concepts of using EVs as mobility storage. There's a sort of a very new application called V2G, or vehicle to grid. That's the concept is to use basically to use EVs as energy storage and just access that energy when during the different periods to help with the loads or to help save energy and save cost, right? And all of this is also driving or promoting a lot of investment in battery cell research. And here we can see that this is just a very quick data analysis to show that the lithium-ion battery pack costs have decreased by somewhat 80% over the last 10 years. And this is making, and of course, this is driven a lot of the driving forces coming from the EV market, the need to have lower cost and higher density lithium-ion batteries, but also it is helping other industries such as stationary energy storage systems to become more cost-effective and more higher power density. So now we've look at some of the trends and some of the drivers. Let's move into the different applications and case study. So before we talk about the actual application, we have to think about why we talk about this today, right? So there is something wrong with the grid, where there's a need to be helped with the ESS. So here is showing a typical demand trend, the daily demand trend for the energy, for electrical energy. And we can see that there's the red line here represents the power plant capacity, and then this other red line, so that means if the demand is going over the power plant capacity, we need to get energy from somewhere else, and then here is the power plant minimum capacity, which means the power plant cannot be shut off. It cannot just turn on when needed and then shut off when not needed, and it always has to produce energy, and there is a minimum capacity for it to be operating. And then during the lows of the demand, there is some need for load shedding. So we're not using that energy is all going to waste. And in order to continue running the power plant, that energy inevitably is going to be wasted. So the solution, of course, we keep talking about ESS, right? So the first application here is the grid level energy storage system, and it is able to help during the peakers. It's able to help release the energy from the battery or from the whatever medium is used to store the energy, and then to able to support this peak demand. And then during the power plant minimum capacity period, where energy is not used as much, it's able to charge the battery and to be able to refill the battery that's used to support the peak release during the peak demand, right? And there are kind of two terms. So the term that's used to describe the battery charging, or the bottom, is kind of called the valley filling, and then at the peak, the top during the release, that's the peak shaving. So here's how the ESS is typically integrated into our grid or the system. So we have the power plants that's generating a set amount of power, and then during the normal uses, it's powering the load. The P load is going to all the different factories, the houses, so it's basically releasing to the grid to be accessed by the consumers, right? And then the thought or the concept is to add a energy storage facility to the site, typically located near power plants, or it can be near the actually consumer side. And what it does is energy will be stored into this energy storage facility during the valley filling period. And then during the peak demand, when all the houses are, all the lights are on, or when the factories are running, then power will be drawn from the energy storage facility to support the actual need from the power plant. And if we take a deeper look into the different components and different levels that need to make it happen, right? So during the power plant, of course, coming from the electric grid, the power coming from the electric grid generated by the power plant, first it needs to be stored. And to store the power, there's usually a power conversion system that happens first, and it typically involves the AC to DC, and then also maybe involving DC to DC converters to charge the battery. And then there may also be, in the same system or the same grid, there may also be different like solar farms or other sorts of renewable generators that are also providing energy through other DC to DC component and inverter and back to the grid. So all of this energy can be stored into the battery during the charging phase, during the low demand, and then during the peak demand, battery will release energy through the power conversion system. So that brings to the point where the power conversion system, to be able to have a efficient and compact system, typically the manufacturers or the system integrators, they use bidirectional power supplies. So the bidirectional means it can support going from to charge, so power energy flowing to the battery, and also during the release, it's taking energy away from the battery and then providing it back into the grid, right? So this is the commercial set application where it's related to the grid. But if we look at a typical residential application, where this is a very simplified graph just to demonstrate the how the ESS is used in a residential setting. So during the day, the solar panel can be charging the ESS that's installed in the individual houses or facilities, and then during the night when the house owner is back or when they need to use the load, for example, it's providing energy from the ESS to the load. So this is also tied to the grid, where it's able to feed excess energy back into the grid or to draw energy from the grid when needed, when the solar panel is not providing enough energy or when there's no sun out, right? And some residential applications are taking this even a step further. So it's not just about the ESS anymore. Some companies are creating what's called a microgrid. So the concept of microgrid is that it is completely, or not completely, but rather somewhat isolated from the actual main grid. And it's independently individually run. So these microgrid applications or companies provide services then to the individual residents or the individual consumers that are on their microgrid. And so the difference here for the microgrid versus the commercial level, the grid level application is that, of course, now the energy conversion and storing is still very similar, but now the storing happens at the usage site rather than directly from the grid. And there's usually a access point or a actual level of energy management at the local site. So now let's look at the different power supplies and the power solutions that we can use for these kind of energy storage systems. So first, let's look at the commercial applications. This is a case study for, this is typically different components of a ESS cabinet, and you can see that it's made of many different battery packs. And of course, there's also the HVAC for cooling, and then there's the breakers or other components for the controls and all that. But the core of the system is the control rack. And so meanwhile, we don't do as much very high power or into the megawatts applications, right? But we do have a lot of different lower power or more complex power supplies to support these control racks specifically. So there are two examples of our for the applications. The first one is using a modular power supply. So modular power supply is able to provide many different isolated outputs. And this is typically used for a lot of the more complex machinery or systems that need different voltages to accomplish different things. And so in this first case, it's used, the NMP, the modular power is used to power a BMS module that is used to regulate and control and maintain individual of the power packs or the battery packs that we saw earlier. And so the other example, of course, is using a rack power that's also built into these. So they like to use these big racks, 19-inch racks or 21-inch racks typically. And the rack power is used to power the communication system as well as the fans used to cool the batteries. So so the auxiliary power and the auxiliary applications, they can very much benefit from the different form factors and different flexible solutions provided by the MEANWELL modular and the rack power, of course. And so before we move forward, let's see if David. So we look at how MEANWELL, we share some of the application examples, right? So how can you share with us how Sager Electronics support the different energy storage customers in your experience?
Kai, whatever the battery technology, Sager has a sales team of technical experts who can focus on power, the thermal management, and battery applications. The power sales team can lean on our power, thermal, and battery design experts at our custom solution centers, where we have electrical and mechanical power supply designers, as well as assembly capabilities in Carrollton, Texas, where we configure the MEANWELL modular supplies that you mentioned. We develop standard products and develop semi-custom solutions. Our solution center, battery solution center that I mentioned earlier, is located in Lisle, Illinois. Heat's always a concern with power conversion and batteries, and we have thermal experts who can assist with active and passive cooling solutions. Sager can provide full indoor and outdoor cabinet solutions with all the associated AC and DC distribution and protection. And of course, Sager is a distributor with a leading inventory position of MEANWELL products in North America.
Okay, thank you, David. So now let's take a deeper look into the products we mentioned, right? So first is the UMP Modular Power Series. And so the modular power consists of a front end that is converting from AC to high DC voltage. And there's also output cards, output modules that can be installed into the front end to support and to provide the different output voltages and the isolated power channels that's needed. So with the UMP1K2, with the dual output module cards, we can support up to 12 isolated output channels and voltages. And the great thing about the UMP and why it's used in the previous example by our customer is that it has the 1U slim mechanical design, so it's able to fit into these 1U power racks or to 1U high systems. And this is very critical for space, very space-limited applications or systems. Additionally, the UMP series supports the programmable voltage or the programmable current functions, what we call the PV and PC functions. What this does is by providing external control signal or voltage, the customer is able to dynamically adjust the output voltage and output current limit to accommodate the different application needs. And in addition to that, there are multiple intelligent control functions such as global or local on-off, or the remote sensing, or the different alarm signals that can be accessed on the power supply unit. And some of these energy storage applications are installed in a lot of the outdoor settings or in very harsh environments. So the unit is able to support operation in temperature range from -30 all the way to +70 degrees Celsius, and comes with the 5 years warranty. And another product we want to kind of point out is the UMP400 Series. This is also a modular type power supply design. And the special thing about this unit in comparison to the NMP we just talked about is that this unit is completely fanless design. So it is lower in power, so up to 400 watts of power, but it's able to fit into a lot more of enclosed or completely sealed systems that does not have active air cooling. The systems can support the operation by conduction cooling or by natural convection cooling. And this unit is able to work by itself. The UMP400 front end is able to operate by itself as a 24 volt or 48 volt system, and it can be combined with the D2D module cards to add additional channels for the output. So next, we also mentioned the rack power, right? So meanwhile, we currently have different levels of different power levels of rack units. So all the way from the RCP1000, that's a single slot power module is 1,000 watts, all the way up to the DRP-3200. That's a single module has up to 3,200 watts of power. And then once inserted into the power rack, we can support a single 19-inch 1U high rack up to 12,800 watts of power. Additionally, they can be connected in parallel to support even higher power systems. And the great thing about this kind of system is that they are able to support more complex and more control heavy applications, especially with the addition of the different controller modules such as the RCP-MU or the RKP-CMU1 for the different types of racks. You can read the power level, the output, the current, the operating temperature, the fan speed. You can access all of those through the controllers. Or if the customer is designing or integrating their own systems, they can also access all of these information for the rack power through PM bus or CAN bus protocols. So the rack power really brings a lot of flexibility and convenience in mounting, especially for a lot of these applications. And another key benefit for using the rack power in these ESS applications is that the units are hot swappable. So meaning if one of the module cards needs to be serviced or maintained without shutting off the power system, the card can be directly pulled out, the module can be removed, and then a new one can be slotted into it without shutting off. So it's able to support the hot swap capability, which is very critical for some of the energy storage applications to ensure the grid stability, right? So that's the commercial side and the power supply suitable for the different commercial applications. So now let's dive deeper into the residential setup, or here is representing the microgrid kind of setup, right? So the energy flow first, of course, we have either the grid that can provide the power to the system or the solar panels. And typically in the system, there's a solar inverter that converts the solar voltage into AC, into the grid-tied energy. And here, once we have the solar inverter converted to the AC, we can have a bidirectional AC to DC converter that's responsible for charging and discharging the battery bank. So once the battery bank is charged or is provided through the energy, the battery bank will then provide power to the inverters at the individual units. So this is where the microgrid concept comes in. For the microgrid management company or the customer, they will then have additional service metering that monitors the individual unit, and then they can talk to charge the individual users or individual residents, right? And in turn, the inverters will power all those AC powered electronic loads in the house setting. So during the low demand period where there's excessive energy generated by the solar panel, the bidirectional AC to DC converter is able to then release energy from the battery bank, or simply not charge the battery bank, and then the energy can also be fed back into the grid or through the net metering, which may be interfaced by the energy storage company and the energy providers or the bigger companies that's not related to the individual services. So here we've looked at a few different components, right? So the inverter products that are providing power to the individual users from the power bank. So we have, meanwhile, we have a new NTS or NTU product family that is covering all the way from 250 watts all the way to 3,200 watts inverter units. And the NTU family is different from the NTS because the NTU family products, they provide a built-in UPS function. So all of the NTS and NTU products, they support 200% peak power capability. And this would be ideal for household applications with motors or with any sudden power peak loads, peak drops. And the unit can be configured via dip switch to select the different AC output voltages and the output frequencies. And the NTS NTU is very energy efficient in that it has very low, no low power consumption power. And we also provide some fanless fanless models for the lower power applications for the lower power need. That's in the 250 to 400 watt range. And there's also multitudes of intelligent protection functions that protects the system, protects the users, right? And of course, the unit also supports a very wide working temperature range from negative 25 to 70 degrees Celsius. So yeah, and as an inverter, it's also able to be powered by lead acid, either lead acid or lithium-ion batteries. So the battery bank can be more flexible as well for different kind of customers or hobbyist needs even. So next is the IRM family. So we didn't really see the IRM products in the power map or the power flow diagrams earlier. But the IRM is actually built into a lot of these service meters or for a lot of these controlling components. They're very low power modules that can be either directly soldered onto the end application PCB or installed into the cabinets with the screw terminals. So we have two different types, the pin type with the output pins or with the screw terminals. Right, so they're very miniaturized onboard type modules, and they're able to support a full range input of 85 to all the way to 205 volt AC. So some of the service metering or the utility access points, they are there's only high voltage accessible from either 277 volt AC or 480 volt AC, and that's where it's very important to have the higher voltage support capability, so there's no extra transformers or no extra power conversion needed to draw power for those power meters or those power applications. Okay, and the whole unit, the whole product family supports very low power consumption. Some models even less than 0.075 watts. So very impressive. And for higher wattage models, there's also over voltage category 3 certification. So over voltage category is more dominant or more relevant in the Europe application. This determines the different areas or different locations the power device can be installed. And over voltage category 3 is already sufficient for most of these power monitoring, power metering applications. So moving on, so meanwhile, we this year, very soon, we'll also introduce a new BIC-2200 product. This is a bidirectional AC to DC converter, and it can be used in the integrated into the application we talked about earlier, where there's the AC to DC component that is bidirectional. So this unit is designed to for a lot of the battery formation and grading applications, so in the battery manufacturers, but also it can be used to support a lot of these energy recycling or energy storage systems. So the unit is able to support grid-tied applications, and so there's a automatic mode where it just runs depending on the battery voltage, whether it's charging it or discharging from it. But there's also fully digital controlled communication protocols which supports the CAN bus digital communication, and you're able to pass command to the unit or to system of the units to tell them to charge or discharge depending on the application needs, right? And in the actual application, up to 5 units can be connected to parallel to support higher power. So this is able to support a lot more of these residential level applications. So like I mentioned earlier, we currently do not have similar products for the megawatt level, which is using a lot of the commercial level energy storage systems. But there's not really many standard off-the-shelf bidirectional power solutions, especially in this power range either, to support a lot of these residential level applications. So this is where the BIC comes in to support kind of this off-the-shelf needs for a lot of these customers. So so this is just a quick summary of the different products we have for the different applications, right? So I've broken down into the different commercial and the residential applications. So for the commercial, a lot of the rack power, they provide power or to power auxiliary equipment or components that may need high power, such as big system level fans, cooling systems, or sometimes even the charging discharging if the system is not as big as some of the massive megawatt level systems on the market, right? And then the configurables, they're able to provide flexible output voltage needs to provide different components, power, so such as the onboard computers or the screens, the displays, or the communication devices, communication modules. Those all need different voltages. So the configurables are able to match what the customer needs and provide the necessary voltage level. And then for the residential, we can have more options into the different components that's actually handling the power conversion, right? So first we had the DC to AC inverters, the NTS, NTU that we introduced for the different levels. And then we also have the AC to DC modules that can be used for a lot of the service metering or the auxiliary control equipment. And then finally, the bidirectional converter, the AC to DC bidirectional, that is able to handle the charging and discharging part for the battery. And before we wrap up, and we want to have one last question. So David, you can see that we've talked about how in recent years, MEANWELL have invested into a lot more resources into products that can support the global-wide Go Green trend. So what is your view on this? Have you been getting a lot more inquiries about the related applications and about the industry in general?
Yes, the trend is for improved efficiencies in power supplies and fans. But the Go Green trend, customers are looking for improved product life and reduced costs as well. Lithium battery manufacturers are looking for ways to reduce manufacturing costs and increase battery life. GM and Tesla, for example, are touting their plans for million-mile electric vehicle batteries with a reduction in the cost of the batteries. That's what all our customers want, a power system and battery system solution that will offer them less power losses and longer life at a reasonable price. But even with the higher efficiencies, getting the heat out can be an issue, and that's why we've been adding thermal design resources, so to help with that total solution and help customers go green.
Thank you, David. So this concludes our presentation. And before we go into the questions, David, do you have anything to add or to talk about?
No, not really. Just want to say thank you for everybody who joined us, and thank you, Kai and MEANWELL, for joining us in this customer webinar. Again, MEANWELL is a proven industrial leader supplying power conversion products and industrial lighting, medical markets, and as you can see, you're going to play a key role in supporting and growing the energy storage market as well. And as a leading distributor for MEANWELL, Sager can help with you and your next generation energy storage product. Thank you.
Thank you.
Okay. Guys, thank you for that. And to our attendees, just a reminder, all webinar attendees will get a link to watch this webinar on demand, which will be emailed soon. And the presentation will also be available at eeworldonline.com and at designworldonline.com. And with that, we're going to get into a few questions we have lined up here. Okay. First one is, does Sager provide test data for value-add assemblies? Anybody want to take that?
Yes, this is David. Sager tests all of our products that come out of our custom solution centers. We test them 100%, and all the test data is recorded electronically, and then we also will provide a paper documentation with the test data. Will be sent with the products, and we ship them to a customer. And usually those test requirements are negotiated with the customer up front as far as, if it's a very simple modification or change or just a wire, adding a wire assembly, a lot of times we might just do a simple continuity test. If it's a fairly major design, then we're going to get into doing, all of the testing required.
Okay, we've got a follow-up question on that. Saying as the logistics lead times are in the news these days, what's Sager's typical value-add lead time?
Yes, indeed. Lead times are getting to be a real issue now. For modular products, that's that Kai had referred to, we can ship those quantities in 20 pieces or less, usually in 5 days. Again, that's if we have product in hand. For power assemblies, our lead time is usually about 2 to 3 weeks of manufacturing, and again, that's assuming that we have all the components on hand. And then as far as lead times, I could maybe let Kai address that if you want to address that. They are going out with a lot of different suppliers at this point, but it's a little hit and miss depending on the product.
Yeah, so right now the typical lead time, of course, right now is a little chaotic with the supply chain issues going on global wide, right? But for the typical lead time, I think Sager Electronics, they're one of our top distributors. We do have they stock a lot of our standard off-the-shelf products, and that's what MEANWELL focuses on. We do standard off-the-shelf products, so with the distributors helping us, they're able to provide very short lead time for the different customer needs. Yeah. Yeah, and I believe Sager, Sager as our top distributor, they stock over 7 million inventory just for the standard off-the-shelf parts, and so yeah, and so the typical lead time, I believe, is if for typical customer orders, if it's not something too special or too big quantity, probably usually depending on stock, if it's readily available, then maybe up to 12 weeks or something that needs to be sourced from the factory. So, yep.
Okay. Another question for you guys. One of our viewers wants to know if a Sager's modification to a standard power supply will void or impact the agency approvals. He's talking about like UL and CE mark and stuff like that. What happens to that?
So for MEANWELL, so I can elaborate first on I think so MEANWELL will do some modifications, right? So the modifications will try to not void the safety or to impact the agencies. But I believe for Sager, because you guys have the value-added solutions center, you guys also try to avoid that. And if it's something that does impact the safety agencies, Sager power systems also work with the customers to get it recertified or to also certify the completed solution. Maybe David, you can add more on that.
Right. Yeah, correct, Kai. So a lot of times we can do just some modifications, add wire harnesses or a bracket or things like that that won't affect the agency approvals. But if we have to modify it, anything that's considered a critical component or specification of the base power supply, then obviously this would impact the original agency approvals. We'd have to go back and have testing redone. If a UL is required on a custom power assembly, we work daily with a UL house local there in the Dallas area for our Power Solutions Center and can facilitate testing and certification for our customers. So.
Cool. Okay, we got a couple of questions relating to part of the presentation on batteries. Guy wants to know about quantum glass batteries. So is that part of the battery research you mentioned?
Most of the, just based on the market data and research, right now, most of the dominant mobility storage or the energy storage applications are still utilizing lithium-ion batteries just because it's very cost-effective and efficient. But I've heard, I think quantum glass batteries is still very, very new technology. And of course, I believe there are lots of resources and the research is going on for this kind of new technology. But I've not heard of wide adoption or integrations into energy storage systems as of yet. Yeah.
Yeah, if I can add on to that as well, this is Dave. What we're seeing short term is that there'll be improvements to the existing batteries that are made. I saw where Tesla is wanting to remove the tab and going with a different termination connection for the batteries, which will reduce cost and basically improve efficiency a little bit. So then after that, I believe the next what we'll see is some new lithium-ion technologies that people are working on, but even those are a few years away. Longer term, I haven't heard anything about quantum, but longer term, there's, I've heard of aluminum air batteries, there's liquid metal batteries, there's flow batteries, but I believe all of those are still in development and they're ways out yet. So it'll be lithium for probably at least the next 5, maybe even 10 years. I'm not sure.
Battery technology tends to move quite slowly, at least in the commercial area. Changing gears a little bit, another viewer wants to know what's the main difference between commercial and residential ESS systems?
I think I can answer this. So aside from the different structure or the topology, like I think we talked about in earlier slides, where the commercial level is typically more used to support the power plants where it's grid tied, whereas residential, a lot of the applications, it's remote or independent from the grid or usually run microgrid. So, but the main difference, I think the purpose is also slightly different. So the commercial level applications are more used to support the grid power demand, like the power shifting or the peak shaving, whereas the residential applications, they're more geared towards the consumer efficiency and consumer cost saving to save money for the electric bills, right? So I think those are the main differences, the key differences between the two.
I'll add to that as well. This is Dave. From the commercial side of the business, they're looking for long-term products as well. They're looking for products that are going to last 20 years, as opposed to the residential customers are probably shorter term than that, right? They're probably more like in the 5 to 10 year range, and maybe using less expensive batteries so they can get a product sooner, but not pay for not pay as much as a commercial customer might be willing to pay. So,
got it. Okay. Next up, the BIC bidirectional product is only 2.2 kilowatts. Do you have anything with a higher power?
Yeah, so the single unit is just 2.2 kilowatts, but the BIC is designed to support parallel operation up to 5 units, which brings the power level up to 11 kilowatts, right? And that is typically sufficient for most of the individual residential systems or residential level applications. But for some of the higher power applications, meanwhile, we currently only have AC to DC, which we can use the rack power, multiple racks combined into a single rack cabinets that can support, in one of our past projects, we supported up to 300 kilowatts in a single power rack. So those are some of our higher power options that can be used for these applications. Yeah.
Okay, kind of a follow-on. Does MEANWELL have any power products for outdoor installation?
Yeah, so a lot of the products we introduced today, suitable for the ESS, we're considering integration into the energy storage systems where the installation or the IP rating is already considered, right? But meanwhile, we also have other product lines, namely one of our called HEP product family. It's for harsh environment. It is IP rated, and we have units up to 1,000 watts in a single fanless convection cooled package that is able to be used directly for outdoor applications. It is IP67 rated. So yeah.
Cool.
Along those as well, Sager can offer cabinet solutions, so we could do small enclosures to larger cabinets for outdoor applications with IP rating and things like that as well. So if they're needing a standard indoor product put into for outdoor, we can offer semi-custom or custom solutions for that as well, besides the standard products.
Mm-hmm. Yep.
Okay. And with that, we've kind of reached the end of our time here. So I'm going to thank everyone for attending the webinar from MEANWELL and Sager Electronics. And this presentation will be emailed to everyone later today. And as I said, it will also be available on eeworldonline.com and designworldonline.com. That concludes the webinar. Thanks for listening and have a productive day.